Converting from conduit to cable tray for electrical systems presents several factors that need to be taken into account to ensure a safe and efficient installation. Firstly, voltage drop. Cable trays can exhibit a higher voltage drop compared to conduits, primarily due to the increased distance between conductors. Therefore, it's crucial to meticulously calculate the voltage drop and verify that it remains within acceptable limits as dictated by electrical codes and the requirements of the connected equipment. Secondly, grounding. Cable trays must be properly grounded to mitigate the risk of electrical shock hazards. It's imperative to ensure that all cable tray sections are securely bonded together and connected to the building's grounding system, adhering to NEC section 250.4 to provide a low impedance path for fault currents. Thirdly, mechanical damage. Cable trays can be vulnerable to mechanical damage from impacts or dropped objects. Implementing protective measures like covers or barriers is advisable to minimize the potential for damage to the cables and the tray itself. Fourthly, spacing. Maintaining adequate spacing between cables within the tray is essential for preventing overheating and ensuring sufficient heat dissipation. The NEC, specifically Article 392.22, provides guidelines on cable spacing within cable trays, dictating the maximum allowable cable fill. Fifthly, minimum fill. Cable trays should have a minimum cable fill to prevent excessive cable movement and potential damage. It is generally recommended that cables occupy at least 40% of the tray's cross-sectional area to provide stability and prevent shifting. Sixthly, minimum bending radius. When installing cables in a cable tray, it's vital to avoid bending them below their minimum bending radius. Refer to the cable manufacturer's specifications for the minimum bending radius to prevent damage to the cable insulation and conductors. Seventhly, cable support. Cables must be adequately supported within the tray to prevent damage or movement. Employ cable ties or other suitable methods to secure the cables and maintain their position within the tray. Eighthly, environmental conditions. Consider the environmental conditions to which the cable tray will be exposed, including moisture, temperature fluctuations, and potential for corrosion. Select appropriate materials and coatings for the cable tray to withstand these conditions and ensure long-term reliability. For instance, in corrosive environments, stainless steel or coated cable trays may be necessary. Ninthly, fire resistance. If the cable tray is located in a fire-rated area, confirm that it meets the fire resistance requirements specified in the building code. This might involve using fire-rated cable trays or applying fire-retardant coatings. Tenthly, transition point. The transition between the conduit and the cable tray should be seamless and secure. Employ transition fittings or adapters to prevent damage to the cables at the transition point. 11thly, inspection and maintenance. Implement a regular inspection and maintenance schedule for the cable tray and cables. Check for any signs of damage, deterioration, or loose connections. Address any issues promptly to prevent potential problems and maintain the system's integrity. 12thly, documentation. Maintain comprehensive documentation of the cable tray installation, including the type of tray used, the number of cables installed, cable spacing, and any specific considerations or deviations from standard practices. This documentation will be valuable for future maintenance, troubleshooting, and modifications. Cable trays offer a versatile and cost-effective solution for managing and routing electrical cables in various industrial and commercial settings. Cable trays come in different materials such as steel, aluminum, and fiberglass, and have different types such as ladder, ventilated trough, solid bottom, and wire mesh. Each one of these types has specific features that make it ideal for certain applications. Steel cable trays are durable, strong, and can withstand high temperatures. Aluminum cable trays are lightweight, corrosion-resistant, and non-magnetic. Fiberglass cable trays are non-conductive, corrosion-resistant, and can be used in harsh environment. Ladder cable trays have a ladder-like structure that allows for maximum ventilation and easy access to cables. Ventilated trough cable trays have a ventilated bottom that provides good ventilation and support for cables. Solid bottom cable trays have a solid bottom that provides maximum protection for cables from dust, dirt, and moisture. Wire mesh cable trays have a wire mesh structure that allows for easy cable routing and ventilation. When deciding what type of cable tray to use, consider the weight and type of cables, the environmental conditions, and the installation location. The NEC provides guidelines on the installation and use of cable trays. Article 392 covers the requirements for cable trays, including the types of cables allowed, the fill capacity, and the grounding requirements. Cable trays can be installed horizontally or vertically and can be supported by walls, ceilings, or floors. The support should be spaced according to the manufacturer's instructions and the NEC requirements. The cables in the cable tray must be properly supported and secured to prevent damage or movement. Cable ties, cable clamps, and other accessories can be used to secure the cables. When installing cables in a cable tray, it is important to maintain the correct bending radius to avoid damaging the cables. The minimum bending radius is specified by the cable manufacturer and should be followed. Cable trays must be properly grounded to prevent electrical shock hazards. The cable tray should be connected to the building's grounding system using a grounding conductor of the appropriate size. The grounding conductor should be connected to the cable tray at multiple points to ensure a good ground connection. Cable trays must be properly maintained to ensure safe and reliable operation. Regular inspections should be performed to check for any signs of damage, corrosion, or loose connections. Any damaged or corroded parts should be replaced immediately. Loose connections should be tightened to prevent electrical hazards. Cable trays offer a flexible and efficient way to manage and route electrical cables. However, it is important to follow the NEC guidelines and the manufacturer's instructions to ensure a safe and reliable installation. Proper planning, installation, and maintenance are essential for a successful cable tray system. The ampacity of conductors installed in cable trays is addressed in NEC section 392.80 and related tables. The NEC provides ampacity adjustment factors for cable fill in cable trays, accounting for the reduced heat dissipation when multiple cables are bundled together. Careful consideration of these ampacity adjustments is essential to prevent overheating and ensure the safe operation of the electrical system. Understanding the different types of cable trays, installation methods, and maintenance practices is crucial for electrical professionals to design and implement safe and reliable cable tray systems.